Assalamualaikum, I am Kiran and today we are going to continue exercise 20.1 and inshallah today we are going to complete it. Three questions are left, question number 5, 6 and 7. Before starting these questions, please do subscribe my channel. Let's start from question number 5. Question number 5 is show that the roots of the following quadratic equations are rational. The condition of rational is we have to make it a perfect square. If it is possible to make it perfect square, it will be proof that the roots are rational. So let's start question number 1 part 1. Question number 5 part 1. So I have already written the question. In this question you can see a is the coefficient of x square, which is L minus m. B is m plus n minus L, and C is constant, which is minus n. So we will apply the formula, which is delta is equal to b square minus 4ac. We will put all values in this formula and we have to convert it into whole square. If it is possible, then we will prove that the given condition that the roots are rational. So let's start. B square, b is m plus n minus L, so let's put it m plus n minus L, and whole square minus 4a is L minus m and C is minus n. L minus m and C is minus n. In this bracket you can see we have to apply the formula of a plus b plus c, where a is m, b is n and c is minus L. So let's start. Let's write the formula first. A plus b plus c whole square equals a square plus b square plus c square plus 2ab plus 2bc and plus 2ca. This is my A, this is B and this is C. So let's put the values. Let's apply the formula now. The delta will be A square, B square and C square means M square, N square. We will replace the values. A square means M square plus B square means N square plus, we will put the values according to the formula. C square, here C is minus L, so it will be minus L whole square. Then plus 2ab plus 2, A is m, B is n, plus 2 bc, B is n and C is minus L, plus 2 ca, C is minus L again and A is m. Bracket closed. Then these three terms are multiplying, so we will multiply it one by one. Minus 4 and minus n, minus minus plus 4n, it will be plus 4n and in bracket L minus m is written. Now more simplification will be done. It will be m square as it is, n square as it is, minus L square. Minus L square means minus L is multiplying 2 times, minus L multiply by minus L, minus minus will be plus and L square, so it will be plus L square. Then plus 2mn. Now it will be plus minus minus 2nl and plus minus minus 2ml. And these values are multiplying, then you will multiply it also. 4n will be multiplied by L first, so it will be 4nl plus minus minus 4mn. Now we will open the bracket. It is m square plus n square plus n square plus 2mn minus 2nl minus 2ml plus 4nl and minus 4mn. Now we will add or subtract the values with the same coefficient. You can see this 4nl can be solved with this 2nl and this 4mn can be solved with 2mn. So let's solve it. The remaining values will be written as it is: m square plus n square plus l square plus 2mn minus 4mn plus minus minus, so minus 2mn minus 2nl and plus 4nl. It will be plus 2nl. We will write plus because 4 is bigger and it has plus sign, and the last is minus 2ml, which will be written as it is. In this question they are asking to prove that the roots are rational, so we have to make it the perfect square. Like if 16 is written, so square of 16 is 4, so we have to prove it like this, 4 square. So if it is possible to make it, to convert it into whole square, then it will be proved that the roots are rational. So let's try it. We have to apply this formula, and we have to convert all values into a plus b plus c whole square to prove, because we are having 3 variables. So it will be m square plus n whole square plus l whole square plus 2ab. So we will put plus 2, a is m and b is n, but it is written minus 2mn, so we have to put minus with one of the value, either with m or either with n. So let's decide it later. Plus 2nl and the last is plus 2ml. Here you can see minus 2ml is required. If I write minus with m, so it will be minus 2ml, and here similarly if I write minus with m, it will be minus 2m. So we will write minus with m to make it the same as we have as it was before conversion, minus 2ml and minus 2mn. So we have written minus with m, so here we have to write minus with the m also to apply in the formula. This all value is equal to a plus b plus c whole square. My a is minus m, b is n and c is l, so it will be minus m plus n and plus l whole square. So according to given condition, you have proved that the roots are rational because you have converted it into whole square. So we can write hence proved roots are rational. Now this part is proved. Now let's move on the second part. Second part is same as first part. In this part again we have to prove that the quadratic equation has rational roots. So again we have to make the perfect square to prove it. So let's start. First we will write the value of a, which is a plus c minus b. B is the coefficient of x, which is 2c, and c is constant, which is b plus c minus a. The formula is delta is equal to b square minus 4ac. So let's put the values in the formula. So it will be b square, b is 2c, so it will be 2c square minus 4. A is a plus c minus b, and c is b plus c minus a. It will be 2 square is 4 and c square will be 4c square minus 4. You can see these two brackets are multiplying, so we will multiply. A is multiplying with the whole bracket, then c is multiplying with the whole bracket, and b is also multiplying with the same bracket. So let's multiply. The first is a is multiplying with b plus c minus a, then plus c is also multiplying with b plus c minus a, and minus b is also multiplying with b plus c minus a. bracket closed. Now we'll simplify it. 4c square minus 4. When you will multiply it with the bracket, it will be ab plus ac and minus a square. ab plus ac minus a square. Similarly, when you will multiply c with the given bracket, it will be bc, c and c plus c square plus minus minus c or a ac. The last is minus b square minus plus minus bc and minus minus plus a and b will be multiplied, it will be ab. Now it will be 4c square minus 4. Same term will be solved now. AB and AB plus AB. It will be 2AB. AC and AC. With one is with plus and the another with minus, so it will be cancelled. Then plus BC and minus BC, it will be also cancelled. Minus a square and minus b square and plus c square. So we will write minus a square plus c square minus b square. Now further we will simplify it. Delta is equal to 4c square minus 4. Now you will multiply 4 with the remaining bracket. 4 2s are 8. AB minus minus plus 4a square minus plus minus 4c square minus minus plus 4b square. Now after more simplification, 4c square and 4c square will be cancelled because one is positive and another is negative. The leftover values are plus 4a square minus 8ab and plus 4b square. Now remember, we have to convert it into perfect square, so let's write, because these are 3 terms, so we will try to convert it into a square minus 2ab plus b square. So it is 2a whole square, this one. This is plus 2b whole square, and the last is minus 2ab. So you will write 2a is 2a and b is 2b. Here you can apply the formula of a square minus 2ab plus b square, which is equal to a minus b whole square. Now you can see a is 2a and b is 2b, so it will be 2a minus 2b whole square. Formula closed. Converted into rational number, so roots are hence proved. Roots are rational. Both parts of question number 5 are done now. If you want to learn question 1, 2, 3 and 4, please visit my previous videos. Now let's move on question number 6 and 7. Question number 6 is, for what values of p and q the roots of quadratic equation, the given quadratic equation, vanish? There it is given that the roots are vanished and we have to find the value of p and q. Roots are vanished means the roots are 0. So let's start to find the value of p and q. The given quadratic equation in question number 6 is x squared plus 2p minus 4x minus 3q plus 5. Here from this equation you can sort out a, b and c, where a is the coefficient of x square, b is the coefficient of x and c is constant. It is given to us that we have that the roots are vanished. Roots are vanished means here I am going to introduce a new formula to you, which is sum of roots is equal to minus b upon a, where b and very well. Similarly, product of roots equals to c upon a. First we will write a, b and c. This is the formula though for sum of roots and product of root that we are going to use in this question, where a is equal to 1, coefficient of x square, b is 2p minus 4, and c is equal to minus 3q plus 5. So let's put it in the formula. The first formula is sum of root, and we are going to find the value of p and q. Sum of roots is equal to minus b upon a, minus b upon a. So let's put the value of b and a. Sum of roots will be minus formula. In formula, the minus sign will be written as it is. Then instead of b, we will write 2p minus for the value of b upon a is 1. So 1 will be written instead of a. It is given to you the roots are vanished. Roots are vanished. Roots are vanished, so it means roots are 0. Sum of roots we will write as 0. Sum of roots is equal to 0. Because the roots are vanished, so sum of root will be written 0 minus 2p minus 4 upon 1. Now from here you can find the value of p according to question 1 is dividing here. When you will shift on the left side, it will be multiplied with 0, and any number which is multiplied with 0 we get 0. So it will be 0 minus 2p minus 4 will be written as it is. Now again minus is multiplying with the bracket. If you shift it on left side and divide it by 0, it will be 0 now. So 0 is equal to 2p minus 4. From here you can find the value of p easily. How? You can take 2p is equal to 4, and after dividing 4 by 2, the value of p is equal to 2. By sum of roots we have found the value of p. Now by product of roots we will find the value of q. So let's find the value of q. Now next formula will be used, product of roots. Product of roots is equal to c upon a. Now let's replace the values with c of c and a. Product of roots, c is minus 3q plus 5 upon a is 1. A is 1. Now product of roots will be put as 0 because the roots are vanished. Again we will write the same reason, roots are vanished. Roots are vanished, so instead of product of root we will write 0 minus 3q plus 5 upon 1. 1 is dividing here. When you will shift on the left side, it will be multiplied by 0, so it is vanished. 3q plus 5 minus is multiplying here. When you will shift with 0, it will be 0. So 0 is equal to 3q plus 5. Plus 5 will be minus 5. When you will shift with 0, minus 5 is equal to 3q. 3 is multiplying. When you will shift with 5, it will be minus 5 upon 3. The value of q you have found is minus 5 upon 3. And the value of p is 2. These are the required answer we have found. Now let's do question number 7, which is the last question of this exercise. Now in question number 7, it is given to that we have to prove that the roots of the quadratic equation are real. Real means delta is equal to 0 or bigger than 0, and they cannot be equal unless a is equal to b is equal to c. We have to prove that the roots are equal if, then we have to prove a is equal to b is equal to c. Now you can see a quadratic equation is not given to you, But instead of this, an equation is given to us. From this equation we have to create a quadratic equation. After that we will start the solution. So let's create the quadratic equation first. After simplification of this equation, you can see these two brackets are multiplying, so let's multiply it. X is multiplying with x minus b, minus, then a is also multiplying with the same bracket. We are doing just simplification to make the quadratic equation. In these two, you can see x is multiplying by x minus c, then minus b is also multiplying with x minus c. Then in the last, these two brackets are multiplying. X is multiplying with x minus a, then minus c is also multiplying with x minus a, and this is equal to 0. After multiplication, it will be x square minus bx minus ax, and minus minus plus ab, bracket closed, plus this bracket will be x square minus xc minus bx, and minus minus plus bc, and in the last bracket x square minus ax minus cx, and minus minus plus ca equals to 0. Now let's open all the brackets. It will be x square minus bx minus ax plus ab plus x square minus xc minus bx plus bc, and plus x square minus ax minus cx plus ca is equal to 0. We are going to create a quadratic equation, so all terms of x square will be written together. Here this is x square, this one is also x square, this is also x square, so it will be 3x square. Similarly, all values of x will be written together. Minus bx minus ax minus xc minus bx minus ax minus cx, all values of x, so it will be written together by taking minus sign common and x common. It will be b, it will be plus a. When we take minus sign common, all signs are changed now. Plus a, then plus c. We already have taken x common, so don't need to write it. Plus b, then plus a, and plus c. Now all constant which is without x square or x will be written together. So the values are ab, bc, and ca. ab plus bc plus ca is equal to 0. 3x square minus b plus b will be 2b, a plus a will be 2a, and c plus c will be 2c and x. And the last constant as it is, ab plus bc plus ca is equal to 0. Now you can see from the given equation we have created quadratic equation. Now we will apply the formula, which is delta is equal to b square minus 4ac, where a is equal to 3. Now you can see a is equal to 3, b is equal to, this whole is b, which is the coefficient of x, minus 2b plus 2a plus 2c, and c is ab plus bc plus ca. So let's put the values. So it will be delta is equal to b square, means minus 2b plus 2a plus 2c whole square minus 4, a is 3 and c is ab plus bc plus ca. Bracket closed. Now let's apply the formula of a plus b plus c whole square in this bracket, because we are having three terms and all three terms are adding. So we will apply the formula of a plus b plus c whole square, which is equal to a square plus b square plus c square plus 2ab plus 2bc and then plus 2ca. This is a, I am indicating a, b and c, so it will be very easy to you to put the when I will put the values in the formula. A is 2b, b is 2a and c is 2c. So let's put the values. Minus will be plus when the power is even, then minus will be converted into plus. So don't need to write minus again, because you know power 2 means number is multiplying 2 times. When minus my sign will be multiplied with minus sign, it will be plus. So just put the values. A square means 2b square plus b square means 2a square, c square means 2c square plus 2, again a is 2b, b is 2a plus 2 bc, b is 2a and c is 2c plus 2, c is 2c and a is 2b. Bracket closed. Minus 4 3s are 12 and this 12 will be multiplied with these three terms. 4 3s are 12 ab and 12 bc and then 12 ca, and minus minus will be plus 12 ab minus plus minus 12 bc and minus plus minus 12 ca. Now let's further simplify it. This is equal to delta so it will be 4b square plus 4a square plus 4c square plus 2 2s are 4 4 2s are 8ab plus 2 2s are 4 4 2s are 8ac plus 8bc, and this is minus 12ab minus 12bc and minus 12ca. Delta is equal to, we will add or subtract the same values. So 4b square as it is, 4a square as it is, 4c square as it is, 8ab and minus 12ab, it will be minus 4ab. Similarly 8ac and 12ac, it will be minus 4ac, and 8bc will be simplified with minus 12bc and it will be again minus 4bc. Now we have to convert it into perfect square. We are having three variables a, b and c. So we have to split the values to convert it into whole square. So let's try to convert it into whole square. First we can take 4 as common. If I take 4 common, it will be b square plus a square plus c square minus 2ab minus 2bc, minus ab minus bc and minus ca. I have taken 4 common from all. Now as you know, we are going to convert it into whole square. So let's start. To convert it into whole square, you know 2ab and 2 a square minus 2ab plus 2 a square minus 2ab plus b square is the formula to convert it into whole square, but here it is 1ab, so we 2ab is required. So what will we do? We will split 4 into 2 into 2, and 1 2 will be sent inside the bracket. So let's do it. Why we are doing this? Because 2ab is required. To create 2ab, we are sending 1 2 inside. So 1 2 will be remain outside, and this 2 will be multiplied with the bracket. It will be 2b square plus 2a square plus 2c square minus 2ab minus 2bc and minus 2ca. But the formula is a square plus b square minus 2ab, but it is written 2b square plus 2a square. So again we have to split it into b square plus b square. Similarly, a square will be written as a square plus a square. Similarly, 2c square will be this question is very lengthy. C square plus c square minus 2ab minus 2bc and minus 2ca. Now we will rearrange the brackets. B square and 2ab will be written with b square minus 2ab, and the last is a square. Rearrange, we have used this. I will underline b square, a square and 2ab I have used. Now again this b square with c square and then bc I will rearrange. So I will write b square. We will take values according to this. AB, so I have taken the values of A and B. Now BC, so I will take B square plus minus 2BC and plus C square. This is done. Now the last is C and A. So this values of C and A and C. All values are done now. So it will be C square minus 2CA or plus a square. Here we are going to use the formula of a square minus 2ab plus b square, which is equal to a minus b whole square. So this one will be 2. This will be b minus a whole square. These term will be b minus c whole square, and the last three terms will be converted into perfect square, which is c minus a whole square. Now in the question this is given that the roots are real, so we will put delta is equal to 0. Real means delta is equal to 0 or bigger than 0. So let's put delta is equal to 0. So delta will be put as 0. So it will be 2 b minus a square plus b minus c square plus c minus a square. Because of 0, this 2 will be divided by 0. It will be 0. So ignores 2. Now it is b minus a square plus b minus c square plus c minus a square. Roots are real means the value of delta is equal to 0. Roots are real unless a, b and c are equal. So we have to prove that a and b and c are equal. So if a and b are equal, if we take b is equal to 3 and a is also 3, then b 3 minus 3 will be 0. Similarly, if I take b is 3 and c is 3, 3 minus 3 will be 0. C minus a, c 3, a 3, 3 minus 3 will be 0. So we will take all values are equal to 0. b minus a whole square is equal to 0. Similarly, this bracket will also be taken equal to 0. b minus c whole square is equal to 0. Similarly, the last bracket is which is also equal to 0. From this we will get the values taking a square root. When we will take a square root of b minus a whole square equal to 0. Square and root will be cancelled with each other and b minus a is equal to 0. From here a will be shifted on the right side and b will be equal to a. Similarly, from this, when I will take square root of b minus c whole square, it will be square and root again cancelled. B minus c is equal to, the root of 0 is 0, so it will be b is equal to c. Similarly, from the last we will get c minus a whole square is equal to 0. Square and root cancelled. C minus a is equal to 0, and from here we will get the value of c, which is a. Here you can see a is equal to b. Here you can see b is equal to c. A is equal to c. From these two equations you can say all values are equal to each other. So it is proved that a is equal to b is equal to c. Hence proved. After doing question number 7, this exercise is completed now. Now inshallah in next video we will start exercise 20.2, but before this please do subscribe my channel. Allah Hafiz.